Hi, also picking up from where we left off in class today, hold on. We're talking about energy levels, sublevels, and things like that. Remember, n can be a whole number. L is going to be from 0 to n minus 1. And then m sub l would be plus or minus l. So for example, if n was equal to 3, the possible L values would be those, and then the m sub l values right here. Okay, so a different way to look at what it is we talked about. That is 2. These are the possible values for L. Here's m sub L, and that's your m sub L. And then if n is 1, L has to be 0, is only the s orbital. Okay. I did want to talk briefly about the shapes of these orbitals. So remember we have our, if L is 0, 1, 2, 3, 4, it's S, P, D, F. Technically 4 is G, but we don't talk too much about those. But these have specific shapes. And so if the s orbital, if L is 0 is the s orbital, it's spherical in shape. The sphere is going to get bigger with bigger n values. So for example, 4s is going to be bigger than 1s. And kind of, again, similar thoughts. They're all spherical, but they're going to be different in size based on the energy levels they're at. The p orbitals, on the other hand, have a dumbbell type shape. So you have two lobes that kind of intertwined, look kind of like a dumbbell. Yeah. This is for the L value equals 1. And the subscripts are going to tell you, hey, is it in the x-axis, y, z, and so on. We have the d orbitals where your L is going to equal 2. The shape is a cloverleaf shape. Again, what you're responsible for, again, not on the exam, but what you're responsible for is to know what those shapes are. It's going to be on the homework. Cloverleaf would be for the D. And then finally, you have the F orbitals that have weird shapes. I don't know. But it looks like this. It's like a complicated cloverleaf, if you would, but that would be the shape for that. Okay. And that's all I need you to know about those.